Mount Rainier is an active volcano. It's a heavily glaciated, close to major cities, and attracts thousands of hikers and families every week. But most visitors are not volcanologists. They don't check USGS seismic alert bulletins. They don't read NPS trail closure reports, nor do they know how to interpret geodetic GNSS displacement graphs or satellite INSAR radar coordinate shifts. The problem is clear. Essential geological safety data is highly technical, fragmented across multiple government sites, and inaccessible to everyday outdoor enthusiasts. Rainier Sentinel was built to bridge this gap. It's a safety companion that translates official volcanic telemetry into friendly human safety guidelines for hikers and tourists. Why use an AI agent instead of a standard static dashboard? First, dynamic orchestration. Telemetry queries are expensive and latency heavy. A static pipeline would execute every sensor fetch sequentially. Rainier Sentinel dynamically determines what to query. If a user asks a simple question about earthquake rates, the agent skips webcam analysis and only fetches seismic data. Second, policy governance. Volcano safety is highly sensitive. The agent is strictly constrained by its central constitution. It operates under secure execution policy, meaning it can only call vetted local scripts, and an official sources policy, preventing it from searching the web or digesting unverified blogs. Let's look at the system architecture. A user prompt is intercepted by the disclaimer agent wrapper, which orchestrates the inner root agent powered by Gemini 2.5 Flash. The root agents coordinate modular, isolated skills located under the skills directory. Rainier status pulls volcanic levels from USGS seismicity catalogs, NOAA storm alerts, and NPS trail hazards. Rainier plume monitors visual webcam steam indicators. Rainier deformation assesses tectonic coordinate changes. To minimize latency, the status skill implements a 5-minute local telemetry cache. Instead of waiting for external network calls, on every turn the cache serves status telemetry in under 0.05 seconds. Finally, after gathering the metrics, the agent invokes the Rainier Safety Summary skill to synthesize a unified hiker hazard report, green, yellow, or orange risk rating, and the wrapper streams the final text with a mandatory disclaimer. Let's see the agent in action. We are running a free evaluation cases from basic data set JSON using our local evaluation running around local eval Python file. Case 1 is the mission greeting prompt. Hello, what kind of safety information can you tell me about Mount Rainier? Here, the agent introduces its capabilities immediately without triggering any API tools, listing that it checks alert status, weather warnings, webcam visual plumes, and geodetic movement trends, concluding with a capstone safety disclaimer. Case 2 is the status query prompt. Is the volcanic alert level or seismic activity normal for Mount Rainier today? Notice the terminal trace logs in real time as the agent runs. Because the user only asks about status and seismic rates, the agent dynamically triggers only the status tool, checks the cached alerts and earthquakes, and returns a compiled summary showing a green normal alert level with minor earthquakes, followed by the disclaimer. Case 3 is the historical data check. On December 15, 2023, would it have been safe to hike near Mount Rainier high elevation trails? Instead of guessing or hallucinating historical telemetry conditions, the agent identifies that its tools only support current data, safely refuses requests, redirects the user to check official historical observatory logs, and offers to fetch today's current status instead, appending the disclaimer at the end. This demonstrates that our safe boundaries are strictly enforced across all conversations paths. How did we build it? Rainier Sentinel is implemented in Python using Google ADK. I pair programmed with anti-gravity AI coding assistant using MCP integration and file modifications tools to iterate on our orchestration flow, and use the agent CLI toolchain to run lints and verify style compliance. The file and telemetry code is fully tested with unit and integration tests. Rainier Sentinel demonstrates how AI agents can act as a bridge between complex earth sciences and public safety. By enforcing strict security boundaries, local scripts isolation, and automated wrapper-enforced safety policies, we can build agents that help people make safer decisions responsibly. Thank you for watching.